Resistors in parallel. Resistors in parallel. So let's say we have a circuit where we have a battery, positive side and negative side, and we have two resistors that are connected to each other in parallel, like so. And we want to have an equivalent circuit where we have the same battery, the same voltage, but this time we only have a single resistor. And let's say these two resistors for our parallel circuit have different resistances, and the one for our single circuit has a single resistance R. Now we want to find the relationship between R and R1 and R2 so that these two circuits will be equivalent. So one thing to realize that if we look at the voltages from A to B, what we find is that the voltage for both R1 and R2 will be the same because they both drop from A to B. So we find that the voltage is going to be the same, namely V1 is equal to V2, which is equal to V. Now another thing to note is that initially we have some current I. And for our equivalent circuit, the single resistor gets all of the current. But for the case of our resistors in parallel, we find that although there is I that it goes into A, what comes out of A, there are two possible paths for the current to flow, namely I1 and I2. So some of the current will flow into resistor 1 and some of the current will flow into resistor 2. And what happens at B is that I1 and I2 flow back together, so then we get our total current I that flows out of our parallel two resistors. So namely, we find that I is going to equal to the sum of the two currents, namely I1 and I2. We also know that Ohm's law says that V is equal to IR. So we know that V1 is equal to I1 R1, V2 is equal to I2 R2, and V is equal to IR. Now since we want to solve for I, we find that I is just going to equal to V divided by R. So we have V divided by R is equal to V1 divided by R1 plus V2 divided by R2. Since we also know that all the V's are the same, we can cancel them out on both sides. We know that the V's are the same. So we have that thus the relationship between these resistances is that the equivalent resistance of a single resistor is equal to the reciprocal of that resistance is equal to the sum of the reciprocals of the resistances of each of the resistors in parallel. So if we have more resistors in parallel, such as something like this, where we have our positive side and negative side of our battery, we might have something like this, where we have three resistors in parallel, then we would add up all three of their resistances, R1 plus 1 over R2 plus 1 over R3. And if we had more, then we would keep adding more. So thus we find that the relationship between resistors in parallel is going to be the sum of the reciprocals of the resistances.